So we've seen the plug-in principle at work. I want to go ahead and ground our knowledge with an example. So let's say we're interested in the average hydration of students in our school, where the hydration is the ounces of water they drink during the day divided by 1/2 times how many pounds they are. So a complex formula, though we can get a lot more complex than this. So let's write the question out. We have a population. The population is all of the students in the school. And we are looking to find the hydration, H, of all of the students, which we will call theta. Unfortunately, getting theta is very, very, very hard. The reason why is because you have to survey every single person in the entire school. So what do? You go ahead and you take a random sample. So you take a sample, and we can assume this sample will be of size n equals 10. Not super important at this moment. So how do we get a good estimate for theta? How do we get a good estimate for the hydration of all the students in the school? We go ahead and we calculate what the hydration of all the students in our sample is. And we call this theta hat. The plug-in principle allows us to say one simple thing, and this is theta hat is as good as we're going to do to estimating theta, as long as n is big enough. We can discuss how big n needs to be in the future, but the important thing you need to know is that just because theta hat is the best that we can do to estimate theta doesn't mean it's a good estimate. For the rest of the class, we're going to be discussing how we can improve upon this estimation and how do we estimate how good of an estimate, even though it's the best one, it might be.